So this little video is going to go over a sample pH problem and how to do some of these calculations. And so the problem we're given is we're told human blood has a pH of 7.41, and then we're asked to calculate the concentration of hydronium, the concentration of hydroxide, and the pOH. So to start, I'm going to write some of our equations that we should know. So pH, as you recall, is equal to the negative log of the concentration of H3O plus. Our pOH is equal to the negative log of the concentration of hydroxide. And we also might recall that 14 is equal to the pH plus the pOH. So when I start this problem, I'm going to start by calculating the concentration of hydronium. And so to find the concentration of our H3O plus, what I'm going to do is use our pH equation. So we know that the pH, we're told, is equal to 7.41, which is equal to negative log of the concentration of H3O plus. I'm going to move my negative sign over, so I have negative 7.41 is equal to the log of the concentration of H3O plus. And so now we just have to get rid of that log. And the way you do that is using 10 raised to an exponent. So we're going to take both sides and we're going to go 10 to the raised to the negative 7.41 is equal to 10 to the log of our hydronium. And when you do this, that 10 to the log on this side essentially goes away, and what we're left with is 10 to the negative 7.41 equals the concentration of hydronium. So now we just have to plug that into our calculator, and I want to show you what that is going to look like. So hydronium concentration is going to equal, and to kind of show you if it helps, I took a screenshot of a calculator, and when you look at this calculator, I want to show you a couple things. We can do 10 raised to an exponent a couple different ways. You can type 10 and then you can use the caret to raise to an exponent. But most calculators also have a 10 to the x button, which is shown here. And notice, because it's the inverse log, it's on the same button as the log. So to access the 10 to the x, we would hit second, and then we'll hit 10 to the x. And so let me show you what that's going to look like on our calculator. So I'm going to go to my calculator here, and I'm going to hit the second function and then hit 10 to the x, and you can see it's 10 raised to the negative 7.41. Enter, and now you see my answer 3.89, and then look far to the right, e to the negative 8, so times 10 to the negative 8. So now we can come back to our worksheet and say the concentration of hydronium is that 9, round it up, times 10 to the negative 8th molar. Once we know that, we can go ahead and find the pOH, and the pOH can be found based on our equation 14 equals pH plus pOH, so 14 minus the pH, and so our pOH is going to then be 6.59. And then we can find the concentration of hydroxide by using the pOH equals negative log of the concentration of hydroxide. And so we now know the pOH is 6.59 equals negative log of the concentration of hydroxide. So negative 6.59 equals the log of the concentration of hydroxide. And so just like before, now we're going to take the concentration of hydroxide is going to be equal to 10 to the negative 6.59. And so we can plug that into our calculator and do it again. So I'm going to say second 10 to the negative 6.59 equals, and here I'm going to get 2.6 times 10 to the negative 7th. So we can go ahead and put that in, 2.6 times 10 to the negative 7th molar. And so there's our concentration of hydroxide, our pOH, and our concentration of hydronium. Thank you.